In this section, we are going to talk about how to create an ideal network. We are going to talk about some best practices about creating an ideal network. The first, we need to keep our network physically safe. In an ideal network, firstly, we should keep our network physically safe. For this purpose, we should keep our devices in a secure data center, which includes fire suppression, professional cooling systems, and etc. And we need to monitor our data center using cameras to prevent unauthorized access. Another important thing we need to focus for physical security should be using separate cabling paths for electric and data to prevent electromagnetic interference. And let's take a look to keeping our network safe from the software point of view. There are lots of network security threats that we can face on internet or local area networks. Common software threats are virus, worm, Trojan, malware, and etc. And to mitigate these threats, we need to use software or hardware, firewalls and antiviruses and something like that. So from the password point of view, let's take a look how we can keep our network safe. Another important thing is to keep our network safe is using strong passwords. We need to use strong passwords for our end devices and network devices as well. And we must encrypt our passwords on network devices by using service password encryption command. And let's take a look from the access point of view. Since SSH encrypts the remote connection session, we should use SSH instead of Telnet. We should also use AAA authentication, authorization, and accounting to protect the access to our network devices. Authentication means users must use username and password before accessing devices. Authorization means we should authorize users with different levels, for example, an operator level or an admin level or something like that. And accounting means we need to record network accesses for device configuration chains. And in an ideal network, monitoring is a really important part today. We need to monitor device configuration chains, device interruptions, and network traffic with monitoring tools, and we need to receive emails from network monitoring softwares to be informed quickly. And let's take a look to prioritizing critical traffic. All traffics in our networks, guys, don't have the same importance. We should prioritize critical traffic, and if there's a congestion in our traffic, our prioritized traffic should use our bandwidth first. We should also use redundant devices and paths to mitigate the device hardware and the cabling problems. For example, let's say that if this device fails, the communication can go ahead by using this device. Or for example, if this cable fails, no problem again. We can go ahead our communication from this path or by using this path or something like that. For easy management and troubleshooting and efficient use of resources, we should use hierarchical design on our network. This design consists of 3 levels, and they are access layer, distribution layer, and the core layer. In access layer, This is the network of the end devices such as PCs, IP phones, printers, and some layer 2 switch and something like that. A distribution is the layer which manages individual branch of its wide array network connections, and the core layer is the layer which provides high-speed forwarding services to move packets between distribution layer devices in different regions of network.